Alright, boys and girls, welcome back to the drive-thru for a remix. Full volume style. Am I blue?
You are.
I'm on. Alright. We're going to redo this video with some volume. Since it's true and false, you're going to need volume. I'm going to go pretty fast. I'll draw pictures when necessary, but if I say anything here that confuses you, come see me. We'll talk about it. Also, I could be wrong, so don't hesitate to come tell me I'm wrong. Alright, if the number of sides of an equiangular polygon is doubled, the measure of each... Is this always, sometimes, never, or true, false? Are you sure?
Yes.
If the number of sides of an equiangular polygon is doubled, the measure of each exterior angle is halved. Okay, well, let's see. The exterior angle is 360 over n. If the number of sides is doubled, let's compare that to 360 over 2n, which is equal to 180 over n, which is half of that. So this is always true. Let's just do a real quick one. A triangle has the exterior angle of 120. A hexagon has an exterior angle. Is this regular? Equiangular. Yep. Hexagon has an exterior angle of 60. That is correct. Alright. The measure of the exterior angle of a decagon is greater than the measure of the exterior angle of a quadrilateral. This is sometimes true because it doesn't tell us that it's a regular decagon. So you got to be very careful about what they're telling you. A regular polygon is equilateral. That's always true. That's the definition of regular. Equilateral and equiangular. An equilateral polygon is regular. That is sometimes true. Think about a rhombus. A rhombus is equilateral, but it's not equiangular. But you can also obviously think about a square is equilateral and equiangular, so that's why it's sometimes. If the midpoints of the side of a scalene quadrilateral are joined in order, the figure formed is equilateral. I think that's never true. If I have x, y, z, and a, if the midpoints of the sides, and I join the sides, I know that this blue diagonal is not going to be the same length as this red diagonal, although could it be? No. If the diagonals are congruent, it's got to either be a rectangle or an isosceles trapezoid. So then when I connect the mid-segments, these two will be congruent, and those two will be congruent, but they're not all going to be congruent. So I think this is never. If the midpoints of the sides of a rhombus are joined, the figure formed is equilateral, but not equiangular. This is never true. I know that the midpoints of rhombus form a what? Well, the midpoints. Here, how to draw a rhombus. Start by drawing diagonals that are perpendicular bisectors of each other. That's a decent rhombus. If I connect their midpoints, I get a square. And there's a lot of reasons for that, and we've done that proof many times in this chapter, so if you don't understand that, you better come see me. If the midpoints of a rhombus are joined in order, the figure formed is equilateral, but not equiangular. So this is never true. An equiangular triangle is isosceles. This is always true by our definition of isosceles, because we have isosceles triangle as a triangle with at least two sides congruent. The number of diagonals in a polygon is the same as the number of sides. Could this ever be true? I'm going to have to make a chart. A triangle has 0 diagonals. A quadrilateral has 2 diagonals. A pentagon, 1, 2, 3, 4, 5. There it is. So that's sometimes true. That one's hard. The exterior angle of a triangle is larger than the measure of any angle of a triangle. That's just sometimes true. Think about an obtuse triangle. Next. Oh, hold on. So we're starting with this one. One of the base angles of an isosceles triangle has a measure greater than that of the exterior angles of the triangle. I don't think that's ever true. If we have an isosceles triangle, these have to be acute. They have to be. The vertex angle could be obtuse, but the base angles have to be acute. And so both of the base angles will be smaller than the exterior angles. Never true. As the number of sides of the polygon increases, the number of exterior angles increases. Always true. As the number of sides increase, the sum of the measures of the exterior angles increases. Never true. What's the sum of the exterior angles, Carson? Always 360. The sum of the lengths of the diagonals of a polygon is greater than the perimeter of the polygon. This is sometimes true. Just think about it. What's the sum of the length of the diagonals of a triangle? 0. No, the lengths. 0. Now let's look at this particular one. We're going to have to do a little Pythag. If this is 3 and this is 4, what's the perimeter of that thing? 15. No, not 15. No, 9 plus 8. So the perimeter of that thing is 17. Using Pythagorean theorem, I could do 3 squared plus 4 squared equals 8 squared. I end up getting 5. That's the most famous triangle in the world. Those diagonals 5. So the sum of the diagonals is 10. So it doesn't work for that one. But if you look at, I don't know, look at this one. This is probably going to be more. And if you get into like a 6-sided figure, you're going to have like, I think 10 diagonals. And it's going to be way more. So this one is sometimes. The acute angles of a right triangle are complementary. Always. They have to add up to 90. The supplement of one of the angles of a triangle is equal in measure to the sum of the other 2 angles of the triangles. These are just getting ridiculous now, Carson. I don't know where you found these things, but that's always true. A triangle contains 2 obtuse angles. Never. If one of the angles of an isosceles triangle is 60, the triangle is equilateral. That is always true. I like that one. If that one's 60, then these add up to 120. So it's 60 and 60. But if this one's 60, that one has to be 60. And that's 60 by the no-choice theorem. If the sides of one triangle are doubled to form another triangle, each angle of the second triangle is twice as large as the... Never. Because then the triangle would go to 360. And it has to be 180. Boom.